Now let's consider another example. It was 2005, and I had opportunity to lead this empirical study. In Frankfurt, a light exhibition takes place every other year. Combined with that exhibition, I led an empirical study for examining the effect of wall color on people's emotional responses. My team set up many color wheels and provided a questionnaire asking people's preference. This table shows you a part of the result. A total of 60 people participated in the study, but not everyone was exposed to the same stimuli. Why? We were afraid of people's feeling fatigue or tired by entering so many rooms. So instead of letting everyone get exposed to every booth, we rather tried to recruit a larger number of people, because 30 people might have been enough if we have planned to put everyone to every colored booth. But instead, we decided to recruit larger number of people, and therefore we gave up letting the people evaluate all rooms. This is a kind of trade-off in design of empirical study. You give up a chance of within test, but you gain more valuable data. The participants can pay more attention to a less number of stimuli. Regarding this experiment, the research question could be whether wall color affects one's emotion, or whether wall color can elicit one's emotion. There is one independent variable and one dependent variable. The independent variable has 6 levels, including red, orange, yellow, green, blue, and purple. The dependent variable was measured in an interval scale. We used a 5-point Likert scale, and 1 indicated for I dislike the color a lot, and the 5 indicated that I like this wall color a lot. Because each color was assessed by differently composed 30 people, for instance, the red color was evaluated by 30 people, but the 30 people were like number 2, number 5, number 8, etc. Whereas the 30 people who assessed the orange color were number 2, number 3, number 5, 6, 7, etc. So the 30 people were differently composed. And therefore, we must consider each group of 30 people, so 30 people for red, 30 people for orange, as completely different people. So we should conclude that each color was evaluated by different 30 people, so different people. Consequently, the between group one-way ANOVA test is a tool to examine the mean difference. So for analyzing the mean difference of the preferences for the 6 colors evaluated by randomly selected 30 people among 60, we need to perform single factor anova, and the input range is from here to here, including the label and column and the labels in the first row, and output, let's assign here. Okay, so there's 30 people, but the composition of these 30 people are different, and the average scores and the variances are like that. Right, so the degree of freedom is a 5 because the number of the color category is 6, and this one is 30 multiplied by 6 and then subtracted by 6, so 174. And then now you know how to calculate this, and then this. So this F value is bigger than the critical F value. So our ratio between group variability to within group variability has reached to even the farther. So it's bigger than the ratio that occurs to this critical value. Therefore, our p-value should be much smaller than 0.05, and we can conclude that people's preference for the wall color of the wall is statistically different, or the color of the wall induces different emotional quality. I have one more thing to tell you about the result. Although we have obtained the statistical significant result, which says that the different color can induce people's different preferences, and that influence is statistically significant, but if you observe the average scores, so average preferences, actually that statistically significant fluctuation, so the mean differences might have been occurred due to very high score of yellow and very low score of purple, because the other four seems to be very similar to each other. So in order to find out where the real difference has occurred, we can perform the post-hoc test. In Korean, it is called 사후 검정. I don't see the Excel offers the post-hoc test option, so let's move to the SPSS. I prepared the data set already. So the first variable indicates the color categories, and second variable is actually the preference, the assessment for preference. Okay, analysis and the mean comparison, one-way ANOVA, and as a factor, so as an independent variable, I put the color, and in the dependent variable, I put preference. And here you can click 사후 분석 or 사후 검정 or post-hoc test. You click here. In social science study, these three methods are typically used, and each method has slightly different or sometimes quite different algorithms. So depending on which technique, which post-hoc test you select, the result can be different. So my recommendation is to select one of these three because these three techniques are the most frequently used in social science study. And comparing these three, Shefei is the sharpest one. The Duncan is somehow so-called mild, the most mild one. Okay, let's compare the results given by these three. Okay, descriptive statistic. Okay, so we already know the result. So the ANOVA test has yielded a statistically significant mean difference, and this starts here starts the result of a post hoc test. First, from Turkey or Turkey test, we don't see, we see some asterisk, and I already explained to you that one asterisk indicates the significance at an alpha level of 0.05. So the pairwise comparison done through the Turkey test between red and purple has statistical significant difference. And also between yellow and orange, yellow and green, yellow and purple. So not all pairs have statistically significant difference, but almost half of the pairs have statistical significance. And according to Shefei post hoc test, you see compared to Turkey, less number of pairs show you the statistical significance. So here you see that depending on the technique you select, sometimes you get the pairwise statistical significant difference, sometimes not. And the Duncan is not provided here because our data was not appropriate for Duncan's test. So one of the three is acceptable. So my recommendation is you test out with all three and take one of them which supports your research purpose. As explained, the post hoc test is followed after the ANOVA test. The purpose is to detect where the difference actually exists through the multiple comparisons. I demonstrated you using the data of wall color evaluation. There are various types of post hoc test techniques. As I said, for the social science studies, Shefei test, Turkey test, Duncan test are usually used. For your more clear understanding, let me show you another example. Suppose you have measured the sugar percentages of cucumbers, pears, and apples. Of course, these two are much sweeter than cucumber. And their average sugar percentages are shown. And let's say the arrow bars are indicating the standard deviation. And if you perform the between group one-way ANOVA test, the statistics might yield the significant mean difference. But the difference actually exists between cucumber and pear and cucumber and apple. So in order to indicate the pairwise statistical result of a pairwise comparison, you can use this kind of indicators, and you can put 1 or 2 or 3 asterisk above. So this indicates that between cucumber and apple, there is a mean difference at an alpha level of 0.05, and here as well. So in this case, the average scores of pears and apples did not yield any statistical difference. Therefore, in order to identify where the difference actually exists, we need to conduct the post-hoc test. Then, let's consider this case. Differently from the wall color case, making a judgment of different color chips by viewing several color chips is much easier task. It takes perhaps even less than 1 minute until you finish the assessment for 6 colors. It also has one dependent variable and one independent variable and one dependent variable. Because there is only one independent variable, it is a case for the one-way ANOVA test. The independent variable has 6 levels. By the way, the levels of independent variable are considered as categories. This means that in ANOVA test, the independent variable is measured in the nominal scale. The 6 types of color is simply 6 different categories. Therefore, it doesn't matter in which order you arrange the color category. The statistic will result the same. Compared with the previous case with wall color, this data sheet is fully filled in. The 60 people were exposed to all stimuli, and they have repeatedly assessed the preference. Perhaps the order of a color stimuli, so the order the color have been presented, could have varied or could have been different in order to cancel out the sequential effect. But all 60 people have assessed their preference for 6 different colors. Therefore, you can perform the within group one-way ANOVA test for this data. I looked up the data analysis function, and I don't see any analysis tool that supports the within group one-way ANOVA test, unfortunately, in Excel. So we should use the SPSS, and you can now compare the data arrangement for between group one-way ANOVA and within group one-way ANOVA, right? So here, the first assessment of red is unrelated with the first assessment of the orange, right? But here it matters. So these data are, these data were made by person 1, and person 2 made these assessments. So here the assessments are related, and indeed you need to give the inputs in such a way in order to perform the within group one-way ANOVA test in SPSS. Unfortunately, I don't have that additional package in my SPSS software, so I'm sorry that I cannot demonstrate you how to perform the repeated measurements or within group measurements here. Perhaps I can record an additional video lecture when I'm using my computer in my lab. Sorry for that.